Be commencing a tutorial series on physics where I will be guiding you through engaging topics, easy to understand explanations, and real life concepts that will make physics easy and exciting. And at the end of each class, we will be assessing practical questions extracted from the Joint Admission and Matriculation Board UTME that will skyrocket your understanding. Greetings, future rockstars, and welcome to Josh White Academy, where we fuel your success with experience-backed strategies and science-based tutorials. If you are new to this channel, I am your host, Josh White, and it's my mission to help you crush high school with confidence and clarity. Please do well to consider subscribing, turn on the notification. Let's get started. So we will be starting off with the topic units and measurements. We will split this topic into two sections. The first section will be talking about units, while the second one will be talking about measurement. We will start this topic by explaining the concept of units. Then we'll explain the types of quantities and units. Then we will move on to talk about how we can analyze dimensions, and we will end the class with practical UTME questions. Actually, no physical quantity is meaningful unless it can be measured, quantified, and assigned a unit. That means every physical quantity needs two things. Number one, numbers or quantity, and number two, unit. Actually, we have two types of quantities or units. Number one, we have the fundamental quantities or units, and number two, we have the derived quantities or units. The first one, the fundamental quantity, I like to call it the basic quantity, the primary quantity, or the independent quantity, because they do not depend on any other quantity. I call them the standard quantity and unit. Okay, so let's see this table. So we actually have 7 of them that fall under this category of being fundamental quantity. The first one is mass. The second one is length. The third one is time. We have electric current. We have temperature. We have luminous intensity. And lastly, we have amount of substance. Yes. The unit of mass is kilogram. Its abbreviation is kg. Length, the unit of length is, the SI unit is actually meter. The abbreviation is m. The unit for time is seconds, sec, or just small x. The unit of current is ampere, A. The unit of temperature is Kelvin, K. The unit of luminous intensity is candela, CD. And lastly, amount of substance, mole. Now please, it must be noted that these are the SI units, but not the only unit. So these are the 7 fundamental quantities. Now the second, derived quantities. and units. As the name explains, they are formed from the fundamental quantities. That means they are the dependent units. I call them the secondary units. They are formed by the combination of two or more fundamental quantities. Now, apart from the 7 aforementioned quantities, all other quantities in their numbers fall under this category. For example, area. What's the formula for area? Length times breadth. What's the unit of area? Since it is length, breadth is also length. So length, meter. You see? Two fundamental quantities will form a m times m, which will give you m squared. Number 2, we have volume. Volume actually has 3 dimensions: length, breadth, and height. And they are all different expressions of length. So that's m times m times m, which will give you what? M cubed. We have speed. Speed is what? Distance covered all over time taken. You see? 2 fundamental quantities coming together. Distance is measured in what? Meter. Time is measured in what? Seconds. So you see, meter per second, or you can just call it ms minus 1. Another example, we have acceleration. Acceleration is velocity divided by time. Please note, velocity has same unit as that of speed. The only difference is speed is actually a scalar quantity, whereas velocity is a vector quantity. But they all have the same unit. So acceleration is velocity over time. That means meter per second all over second, which will give you meter per second square, or ms minus 2. We can continue like this, but let's advance. Now I want us to talk about dimensions and how it can be analyzed. Physical quantities are expressed in terms of the dimensions of fundamental units. Like, for example, mass. The dimension of mass is capital M. The dimension of length is capital L. The dimension of time is capital T. The dimension of current is capital A. So please, this should not be mistaken with units, because the unit of mass is not M, it's kilogram, but the dimension is what we've listed here. So we will be using this to analyze dimensions. Area, as we've said before, length times breadth. So the dimension is actually length times L, which is what? L square, not M square as in units. Let's talk about speed or velocity. Is what? Distance over time. That's what distance is, what? L divided by time is what? T. So is what? LT minus 1. You see it? We have acceleration is velocity over time. That's L over T divided by T. As we've said, it will give you LT minus 2. We have number 4. We have force. What's the formula for force? Force is mass
multiplied by acceleration. Mass is what? M. Acceleration is LT minus 2. You see the flow? So let's stop here. Now let's use the next minute we have to crush JAMB questions. Come with me. Okay. Let's assess this question. The internationally agreed system of units SI for physical measurements are A. IB, feet, seconds, B. gram, meter, seconds, C. kilogram, meter, seconds, D. centimeter, gram, seconds, E. kilogram, centimeter, seconds. We've already answered this during the class, that the SI unit for mass, length, and time is kilogram, meter, and seconds. Please, if you desire to answer the question before I do, you can do it to just pause the video and answer before I do. So our answer is kilogram for mass, meter for length, and seconds for time. The next question. Which of the following is a fundamental unit? Newton, watt, joules, seconds. Cheap question. What do you think our answer is? Our answer is second. That's the SI unit for time. The next question. Which of the following is not a fundamental SI unit? In another word, which of the following is a derived unit? We know meter is a fundamental unit for length, ampere for current, Kelvin for temperature, second for time. Radian is not a fundamental SI unit. Let's continue. It says, which of the following is the dimension of pressure? You see, for you to be able to analyze dimensions, you need to know the formula of that physical quantity. Please, if you desire to know how to master formulas as a physicist, please do well to check out the video I made on how to master formulas easy. So, let's continue. So, the formula for pressure is equals to force divided by area. Now, if you remember from our previous class, the dimension for force is MLT minus 2. Whereas the dimension for area is L squared. Because force is mass, M, multiplied by acceleration, LT minus 2. And area is length times length, or length times breadth, L squared. So from this, M, L, based on indices, L1 minus 2, division rule. It will give you L minus 1, T minus 2. Wow. So our answer is A. ML minus 1, T minus 2. Let's continue. Hope you are enjoying this lecture. Please, if you are, please don't hesitate to subscribe. It encourages us and it enables you to see when more of videos like this comes up. Turn on the notification, like, comment. So, the dimension of work and energy are, work and energy has the same dimension. Now, what is the formula for work done? Work done is equals to force multiplied by distance, by the perpendicular distance. So remember from our previous question, force is what? MLT minus 2. and distance is what? L. So multiplying it by product rule of indices. So L times L will give you L squared C minus 2. So you see our answer, ml squared C minus 2. Similar for that of energy. Let's continue. The next question. The dimension of power is, now, power is the rate at which work is done. That means power is equals to work done divided by time. We just finished work done, and our dimension for work done, if you can still recall, is ml2 T minus 2. So ml2 T minus 2 divided by time. If you're asking how we got work done, please reverse the video and get that. So work done is ml squared T minus 2 divided by time. Okay? You don't need to write the full word. Divided by time. So our dimension is ml squared T minus 2 divided by time. So by indices m, the next thing is L squared. There are two T's here. So minus 2 divide in indices is minus. So minus 2 minus 1. Minus 2 minus 1 is equivalent to minus 3. So our answer is ml squared T minus 3. ml squared. Wow, our answer is what? A. Let's take one more question. The value of x, y, and z respectively in the expression m x l y t z for the universal gravitational constant G are. So this is Newton's law of universal gravitation, and it has a formula: F m squared all over r squared. It stated that the force is directly proportional to the square of the masses and inversely proportional to the square of the distance between the two masses. So this is the formula, and this G here is our universal gravitational constant. So for us to be able to find the dimension of G, we must make G the subject of the formula. And to do this, we will cross multiply. F times r square will give you fr square is equals to gm square. We are looking for G, so we will divide both sides by m square. So our G is equals to fr square all over m square. Now we can now analyze the dimension. Force is mlt minus 2 multiplied by radius is similar to length. So radius square, that's L square all over mass, that's m square. Now let's do the indices here. So m is up, m is down, and here is 1. So 1 minus 2. So it will be m minus 1 L. There are two L's here. L1 multiplied by L2 will give you what? L raised to the power of 3. And T is only 1. So it will be T raised to the power of minus 2. So M minus 1, L3, and T raised to the power of minus 2. So from our expression here, M will have what? M will have X will be what? Minus 1. Y will be what? 3. And Z will be what? Minus 2. Minus 1, 3, and minus 2. B is our answer. I believe in this few minutes we've spent, you truly understand all that has been done. Please do well to comment in any areas we're confused along the line or anywhere we lost you. Next series, we will be coming to talk about measurement. So please do well to subscribe so that you will receive notification when it comes. I remain your host, Joshua, leaving to catch you another day. Shalom.